What's up? Y'all doing good? On some chill shit today, bro. Some calm shit. I do want to do some stuff. Um, I was gonna do this stuff off stream, but I was like, fuck yeah, I can stream it too. So I'm gonna look for a part. I need to get an AliExpress order. So I'll be buying shit from AliExpress for my engineering projects. So like this shit's been on pause for a while now. I gotta resume this shit. So I've been busy with all the editing. Sorry, let me turn on the fucking music. Okay, so I've been mad busy with shit, with editing the YouTube videos you guys are hopefully watching and shit. The the amnesia streams, yeah, well, the TikTok. Yeah, I don't even think I don't know if you can tell right there, but the shit's already got dust on it. It's chill though. It has a little film on top. But yeah, this is something I'm trying to resume. It's been maybe like a month and a half, maybe even 2 months. I'm not sure when the last time I touched this was. But I need to get back onto it. The reason I stopped was because this guy right here, this little dude, it's got like the brain, you know? This guy, this guy thinks about all the shit, all the sensors, all the LCD sense commands, saying, "Yo, turn on, bro, display this," or this thing right here measures heart rate, so grabs the data from there, and process all that. And he's the nexus, the connecting point on everything. So this guy's important. I fucked him up though. I fucked him up the other day. By that I mean like I was trying to learn how to program it. I think I programmed it wrong because I think the bootloader, it's not booting. Like it turns on, but it won't go into it won't load the bootloader. So in microcontroller terms, there's whenever you turn on a little device like this, it loads up a preset like code, I believe, which is called the bootloader. It's what allows the computer, to see everything, to connect to it and everything, and program to it. If I can't get to the bootloader, I can't program it. So I need to fix this guy. One way to do that is to get an SDW debugger, I believe. So right now I can only program it through the USB port right here. It's a USB-C. I can only program it through there, but since I fucked up the program through there, I can't get it to program through there. So I'm gonna try programming it through another little thing here behind the microcontroller. Let me show you. So behind the microcontroller, there are these 4 little pins. You see those little square pads? They're on your right, on the right of the board. Those 4 pads. Um, they're to con. They're so you could program it via another method. The other method is programming it using the SW debugger that I was talking about. So which stands for serial wire debug. And the architecture of this MCU, I have to choose a debugger that allows you to communicate with this type of architecture of the microcontroller. And the architecture, maybe I don't think the correct term is architecture, but like um I don't know. But it needs to communicate with this type of microcontroller. There's a lot of different types of microcontrollers. So yeah, I need to make sure I'm talking the same language. And yeah, we need to get that debugger, so I'm gonna try to get that today, on stream. We'll see how that goes and shit. Hopefully, you guys don't get too bored and shit. But we'll hop on some Valorant too for a bit. It shouldn't take that long for us to get that order in. I did want to see what else I want to order for this thing, because right now I'm building a smartwatch, right? Well, yeah, I'm gonna need a case, but this is all prototyping. Um, so I wanted to detect heart rate. I wanted to detect footsteps, which the footsteps is gonna be coming from the accelerometer here. Um, and then I wanted to have a display, so I should be able to pull it up. It's got a little display saying it's like a little fitness tracker. So heart rate sensor. Okay, my beats per minute, and then okay, this is how many steps I got in, and yeah. So I think that's all the sensors I need. But I also want to do this wireless, so now I gotta worry about power management and well, yeah, power management. Oh, the battery is something else I also wanted to order. I have this stuff kind of like planned out already, but I've been delaying the order just because um hopefully it doesn't show my fucking address, bro. I ain't fucking doxing myself. Let me see. Let me make sure I don't dox myself on this shit. Let's see. So, which account was it? I think it's this one, dude. Also, for some reason, my jaw's been fucked. Like this right here, disconnecting point, this jaw, and then the what is it called? This bone right here, like the connecting point here. It hurts when I bite down or when I open my mouth. Ow. I don't know what I did with that. Hopefully, I don't think it's from that one time when I ate a big ass bite from my sandwich. For some reason, after I got out of the shower, it actually it's hurting more. Oh, mm, okay. So we got here this. Oh, the thing is, oh, shipping is just $2. Also, I've been waiting for the paycheck to hit. Oh, fuck. Does this say my address or no? Okay. No, it does not say here. I think I can screenshot this. Okay. Yeah, yeah, I know. I don't know why my this happened last time though, a while back. It was the same issue. But I think my tendon is just like strained or something. Mm, oh shit. Okay. Mm, you guys could see this, right? Oh my fuck. Mic good. 1 2 3 1 2 3. Check 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 check. Okay, looks fine. Mm, okay. So, let's see here. Mm, Mm, um, let me open something else real quick. My notebook with all my notes on this shit. It's on. Just have a Google Doc with it. Let's see here. Boom. So yeah. Let's see here. Um. Okie dokie, okie dokie, okie dokie. So here we have. Um. Okay. So I also took a little bit notes from last time I fucked up. That's good because I think I would forget right now. Okay. So. So last time, this was on February 18th. That was 2 months ago, basically. So here we see, Soup, are you still there? What do you think about um the chat staying up on the top left for like forever, basically? Like, do you think that's fine, or do you think it'd be better if because I have two different types of chats on my desktop stream. Um, if you chat something, it'll stay on the screen for like 15 seconds and then it'll disappear. But for my full cam stream like this, I have damn, I did fucking magic there. What the fuck? For my stream like this, I have it so that it's using it's using what's it called? Um so it stays permanently on there. Do you know what I mean? Like the chat messages you type will stay on the screen permanently. While if I go on my desktop stream, I use a different overlay, so then the chat messages disappear after 15 seconds. What do you think is better? Well, it will be on screen, but I'm saying like the message you send right now is gonna stay up there for the rest of the stream unless other people type and it goes up, up, up. But if no one types anything, that's gonna stay there until the entire stream, until the stream ends. Versus your messages stay up there only 15 seconds after you type it, and then it slowly fades away and it's gone from the screen. Yes, for YouTube. Okay, okay. I Yeah, I was thinking that too. I was like, yeah, I'll keep it in there. Oh yeah, also, remember how I downloaded Outlast? I'm gonna need, I think I need to be in your Steam family for that. Oh, I could just go on your account. Oh shit. So here it says, mm, So I did try using this new thing called Zephyr RTOS, which is an operating system like Windows, but it's RTOS, so it's like a smaller version on the microcontroller. I tried doing that, but then it was like I don't think I could have used it because of the development board I bought. Oh, okay, I see. I'll I'll just we'll talk about it off stream. Um yeah, I was gonna say that. Okay. Mm, actually, where am I stuck here? So yeah, there is an extension for one of the softwares I use. Um, so my board doesn't get flashed via. Mm, so to flash my little microcontroller using Zephyr, I need a SWD hardware programming interface, which is the little debugger I was talking about. So I was like, okay, I can't use Zephyr because I need SWD. But then when I tried programming it using a more simpler method, um, it failed, and this was because okay, I have a chat. Let's see. Mm, let's see what they say here. Damn, I need to get a refresh on this shit. Mm, mm, I forget why this is gonna fix it. On this screen, it disappears. So like, look, you see your chat right now? It's gonna disappear in 15 seconds. Just give it a sec. Mm, um, see, that was longer. I felt like longer than 15 seconds. Versus on my normal full cam stream, it's just still there. It doesn't disappear. So whenever I play games, I would use this one and it would disappear. Um, let's see. So why is this gonna work? Mm, mm, alright, I'll go on my desktop right now. So I have this is the debugger I think I want to get. Let me see. I also linked it in my Google Doc here. I think it's this one actually. This might be it right here. Yeah, so you see Cortex M0, that's the CPU architecture, I think, right? So Cortex M0 is the smallest bit 32-bit processor we designed. Deliver 32-bit percent at an 8-bit price point. So this is a group of RISC ARM processor cores. So you see how it says here it supports all these MCUs. Mine is this one, Nordic, and it's the NRF52 series. This one right here. So this one should work. Um, Let me get a refresher on why my shit died though. Oh shit, it's gonna take too long to figure it out. But I'm pretty sure that's what I need. I'll get this guy, which I already have here, and oh, also the battery. I think it's a good sizable battery. It's I think it's I forgot how to read this. It's 30 millimeters by 20 millimeters, I think. I think so. Let me see. Real quick, real quick, real quick. Specifications. Um, see here. So we're getting the I think it was the 2020 the 30 2025, and the 30 2025 is thickness, width, length, thickness 3 millimeter in thickness, 20 millimeters in width, and 25 millimeters in length. That's a perfect size just because I want to fit it on a watch that I have. So this little fucking dude, I'm gonna disarm this shit and put it inside here. I low-key doubt it's gonna fit. Um, that's a pretty thin profile, especially for my first time building some shit like this. But fuck it, we ball, bro. And the milliamp hour is 140 milliamp hours. I think, honestly, I think it's fine. It's whatever. I think it's whatever. I'm fine with recharging it multiple times, bro. So that's two things. This guy. It's already 21 fucking dollars. How? How is this? Uh, How is this $21 already? What? Oh, because I'm getting two batteries. Should I get two? There must have been a reason I chose two. I think it's because sometimes the battery could fail. That's that. What did I want this guy? What was this guy again? Mm, I think this is I think this what is it? Um, drive IC description. Fuck, what does this guy do again? I might just have to search it up, bro. It's a 3.3 voltage low dropout voltage regulator. Okay. This is just a voltage regulator, so it smooths out my voltage in case if there's little spikes and shit. So it smooths out my voltage to 3.3 volts, and then I'll be able to get a smooth 3.3 volts. Why do I want 3.3 volts? The battery is 3.7. Mm, I think it's for my MCU. So I'll be putting in a 3.7 voltage battery, and then through the voltage regulator, which the voltage regulator should bring down 3.7 to a smooth 3.3 volts, and it should supply power to my microcontroller. Not this guy, but the guy I showed you. That should be good. Um, let me show it to you guys. So the power is going to work with battery plus minus goes into the MCU, the plus, and then that shit is connected to HR, heart rate sensor, and then what else is there? Heart rate sensor, and then it's connected to um what was the other thing? It was the accelerometer, and then yeah, that's how it's getting power. But then also I believe negative, there's a negative terminal here as well. Oh, and this also is connected to the LCD screen. Um, and then I also want to recharge this battery, so I need something that'll recharge it. So, which is called the power management chip or something like that. Let's see. And we already bought that. It's somewhere here. Hold on, let me hide my screen real quick so I don't leak anything. Orders. This guy right here. So this guy is our little dude that's gonna recharge our battery. Um, yes sir, yes sir. And that's our little dude right there. This guy's gonna recharge your battery, plug in our USB-C, and then battery plus, battery minus, boom, boom, and good. So I'm not sure how the wiring is gonna work here though, because we have the battery management IC, battery charger, a TP, modular charging port with protection, dual functions, 1 amp lithium ion. So it provides 1 amp. So that's how fast it'll be charging. It'll be charging at 1 amp. How slow is that? Can we calculate that? 1 amp into a 140 milliamp hour battery. Let's see, calculator. I wonder if this is how it works. So we have 1 amp going in, and we have 140 milliamp hours. So what does that mean? 1 amp. Um, how long does it take to charge a 140 milliamp hour battery at 1 amp? Theoretically 0.14 hours or 8.4 minutes. That is a small ass battery. Oh, what the fuck? So what is it? Charge time equals capacity over current. So 140 milliamp hours. Alright, the units are milliamp hours on the top, and then you divide that by milliamps. Should give you hours. So 140 divided by what fuck? 40 milliamp hours divided by current in milliamps. So 1 amp is equal to 1000 milliamps. 0.14 hours. How long? Let me see. How long does a 140 milliamp hour battery last? Wait, now I'm wondering if the 140 milliamp hours is enough. Divided by the load current. So the load current, if this stuff, I need to see how much current each one of these is drawing. Maybe I should buy the battery later. I think I should just do this stuff. I should just do this stuff, and then why is my camera freezing, bro? Okay. I'm thinking I buy this stuff right here. And then I could do mm, and once I calculate, so like this, I1, I2, I3. So current 1, current 2, and current 3. And there's only one current going in. So that means, let's say I total, right? I total. And due to Kirchhoff's laws, which I learned from physics, whatever goes in goes out, right? So that is equal to how much it splits out. I2 plus I3. So what I need to know is how much current IT is, how much current is drawing out of the battery. Once I know that, I can see how fast the battery is going to discharge. Okay, okay. Should I buy the... Maybe I don't buy the battery yet. Hmm. 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 Yeah, I don't think I will. No, but then... Oh, I gotta save myself some shipping fees and shit. Like, I still have to buy this. I think we should try it out. maybe we can maybe make us some random values here for the current. It's the heart rate sensor. Let's see how much can that draw. There might be spec sheets here. Hold up. So let's see LCD right here. Boom. And what else do we need to see? The heart rate sensor. Heart rate sensor and the accelerometer. Oh, and then there's current from the actual board as well that it's drawing. So the battery is actually supplying all these four components. So here's the LCD I bought. Any specs? How much amps? How many amps does it draw? Programming material, IPS, resolution, driver IC, display, size, panel, interface type, work voltage. See, after that LDO, we could actually supply the power to this guy directly. I don't even know if our microcontroller can supply power. Let me see. No, I think we'll just have to share the power. So technically, the battery is also going to this guy. Oh, hold up. This guy, and this guy. So there's current here, 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 and here. So scratch this, scratch this. Um, fuck. How do I? Oh fuck. Okay. Okay. So we have one. Oh shit. Um, I1, I2, I3, I4. Okay. So there's just four currents, and I need to see how much current I'm drawing. Okay, let's see that four components for drawing current. Um, so this one, let's see. I think the LCD would draw a lot, because I mean it's powering it's turning on this entire crystal here. I can't find it in the spec sheet, so you know what we do when that happens? We go straight to Google. We go to Google if we can't find it there, and it's gonna be hard to find it too, because it's let's see. What if I just search a data sheet for this guy? Searching up the data sheet for the driver IC. So this is the guy that drives the LCD. I don't think it's accurate though, because it doesn't include the LCD. Um, one microamp. Logic high level input current. Logic low level output. Leakage current. All right. I'm gonna cut to the chase and just straight as ChatGPT, bro. I have this. I'll just give it the name of the product. See if you could find anything about that. I have from AliExpress. How can I calculate the current draw? This guy in this. Wait. Oh, why does my ear hurt? Oh, I wonder if it's my jaw. Does this guy show it? Dissipation power. Supply voltage. Wait, what? 5 volts? What? The NRF5280 has a 3.7 volt lithium battery. What the fuck are you on about, bro? I don't see it. There is no battery on that shit, bro. You are tripping. Mm, it's already got a battery charging chip. Does that mean I didn't have to buy it? Oh, sure. Wait. B plus, B minus, then VCC. Wait. I think I have to just connect the battery to the B plus, B minus here and here. And it's already charging it. And then from there I connect to the LDO and then connect to here and here. Hmm. Well, maybe I just wasted money on this. It's already bought though. So let's see. So I want, oops, oops. So let's go to the cart real quick. Um, so here, mm, this guy is fine. This guy is fine, I think. It's fine to try it out. And then this guy, probably gonna need if we want to do wireless shit. Want him to power it from the battery. And I think that should be it. Let's see if I checked for now. Let's see if we could get some current values here. Mm, let's see. So this guy, I couldn't find the value, the current draw. I'm pretty sure it's because current draw is just, it's just like, it depends. It just depends on what you're like displaying and shit, and how big of a load you're putting on it, I think. See. Um, okay, so ChatGPT is telling me that the current breaks the display in two loads. So A, the logic. Okay, that makes sense. The driver, the SPI interface. This powers the controller IC and internal logic, typical 2 to 10 milliamps. So I'm gonna guess 10 milliamps. Let's draw that in. So this guy, I4, equals 10 milliamps. Plus, this is for the driver itself. Now we need the backlight. Is 20 to 60 milliamps. So let's say 60 milliamps. Um, and that should be it. I'm trying to calculate the max amps gonna draw. Um, what the thing is, I'm not gonna be able to. My camera freaking froze again, bro. Why you freezing on me, brethren? So, thing is, I don't know how to measure current because I don't have a freaking ammeter. Okay, be current versus time. Use USB power meter. Okay. So let's say it's 70 milliamps. It depends. Still, the backlight depends on how often I have it on and stuff. But I'm just doing worst case scenario, bro. Worst case scenario here is where the fuck is my mouse? Oh, 70 milliamps for the LCD. Now for the accelerometer, let's check it out. Um, this is the heart rate sensor. This is the heart rate sensor. Specifications. Uh, DIP dual inline package. I'm not sure what that means. Digital sensor, biosensor. Okay, heart rate sensor. Um, mm, Photo dissolution method. The measurement of pulse and blood oxygen saturation is performed by using human tissue to cause different light transmission when the blood vessel beats. Light source specific wavelength of light emitting diode selected for oxyhemoglobin and hemoglobin in arterial blood. At this time, the light reflected by the human tissue is received by the flow electron converted to electrical output. The average pulse VN 1.8 volts to 15 volts. 3-bit pad selects a pull level of the bus. Uh, there's nothing about the current here. I'm definitely not looking in the right place or not thinking about it right. Okay. So this one is considered ultra low power. Let's see how much it draws. What about come on, ChatGPT, tell me, give me an estimate. Mm, its consumption is highly dynamic. Depends almost entirely on how you configure it. Right, because if I'm gathering data every second, it's gonna draw more current than if I'm gathering data every 10 seconds, right? Break the power into components, okay. LED pulses dominant. Yeah, red and iron LEDs. Measure front end and ATC measures reflected light. The control power, LED current, biggest factor. Pulse width, sample rate, number of LEDs. So average current is equal to the current draw of the LED times the duty cycle, which is what percentage of time it's on, plus the current of the system. Okay. Typical configuration 10 milliamps pulse width 100. Um, Mm, so at max settings, it's 10 to 20 milliamps, but it's rare, considered rare. Okay. Typical is 0.5 to 2 milliamps, but it can go up to 10 to 20 milliamps. I'm gonna go for like, I'm gonna say it's like, I'm gonna say 5 milliamps. So it's the accelerometer, so I3 is 5 milliamps. And then HR sensor. Wait, no, that was a heart rate sensor. 2, 5 milliamps. And then let's see what else is there here. Uh, wonder how long this battery's gonna last. It's already at 75. It's like 2 hours, bro. This shit is not gonna live, bro. This shit gonna die right away. Okay, let's go next component, which is heart rate sensor done, accelerometer. The accelerometer is also very dependent, so I'm asking ChatGPT what does he think, or they think, or it thinks. Maybe I'll buy it tomorrow. We're getting some good research today. Mm, let's see what are the estimates here. Yeah, what's up? My bad, chat, but we good. Oh, that was my housemate. Let's see here. So now, next component, what does ChatGPT say? It's much simpler, okay. Very predictable and low power consumption. It's one of the easier parts to budget. Okay, okay, okay. Three internal blocks, an accelerometer, a gyroscope, and digital processing, which is filters, temperature sensor, blah, blah, blah. Oh shit, this shit has the temperature sensor. Did I choose that knowing that? No way. Damn it. They should go to it now. Wait, they should low-key go to the IC. Okay, typical current consumption from datasheet. Okay, well, supposedly this one has its power consumption in the datasheet. 8 kilobyte first in first out buffer. That's what FIFO stands for. You better take tremors, tilts, movements, knocks, count steps, and even read temperatures. People reading accelerometer, blah blah blah. Each pin of blah blah is disconnected with one side of the board having power and I square C function, while the other side has pins that control the SPI function and interrupt the output. Okay, we got SPI and I squared C here, which are two different modes of communication. Product application, product characteristics, power consumption 0.9 milliamps in combined NERM mode and 1.25 milliamps in combined high performance mode. Let's see what does ChatGPT say. Do they know? Does it know? Uh, this is 3 to 6 milliamps here. Damn, why is it giving me a higher? Okay. Realistic current for my use case is 0.12 milliamps. Tiny. So I squared C has this I squared C or SPI draw more current. More current. So the protocol that draws more current depends on the operating speed and implementation details as neither is universally higher. I squared C generally draws more current at low speeds due to static power consumption from pull-up resistors, while SP often draws more current at high speeds due to dynamic power consumption from rapid line switching. Okay, well, they have their own ups and downs. Um, so the XML saying that it's 0.1 to 0.2 milliamps, but ChatGPT doesn't know I'm using it for multiple cases. Doesn't know that I'm using it for um temperature reading as well. So accelerometer is, let's go with the spec data. She says 1.25 milliamps. And then holy shit, I ain't reading all that. Mm. Trying to see if there's a milliamp reading on that big old paragraph. Um, okay, no. Okay, let's say this is it. We got I2, I3, I4. Now we need the MCU. How much the MCU? Oh, the MCU is highly dependent though. Depends on how much shit I have. It's gonna vary a lot, bro. But what does it say here? Dissipation power. I think that's how much heat it generates. Oh no no no! It depends how much heat it can handle. So it releases 1 watt of heat, I think. Let me make sure I'm right. Part is process of which electron is converted into heat energy as current flows through a resistor. Blah blah. Representing energy as lost as weight rather than useful work. This phenomenon occurs due to electrical resistance and is measured in watts and serving as a critical factor in circuit efficiency, thermal management, blah blah blah. Power dissipation is calculated using, okay, this is the process by which electrical energy is converted into heat energy as current flows through a resistor or other electrical components. So yeah, that's how much power it is turned to heat. Uh, Operating temperature 1. Okay, never mind. I don't think this is right. I think they don't know. Mm, let's see. Charging current. When the boost is connected, the charging current increases from 100 milliamps to 300 milliamps. Wait, I might be reading the so this thing can charge at 300 milliamp hours. So remember it was 140 milliamp hour battery divided by 300, which is gonna take around 46 minutes to charge, or 0.46 hours, which is almost half an hour to charge, to fully charge. So far, this 140 milliamp hour battery does not seem good. I don't know capacitors. I'm probably not gonna go to the 300 milliamp hours. Wait, what if it's 100 milliamp hours? 140 divided by 100. 1.4 hours, so 1 hour and a half. See, this is the bootloader I was talking about. So I wanted to enter in bootloader, but when I do this, it used to do it, but once I programmed it, it didn't do this anymore. So it doesn't even enter the bootloader. Um, so let's see how much current this is gonna draw. It also depends on I think how efficient my programming is. Bro, mother trucker. Hold up, don't delete the message yet. I'm gonna copy the link, then I'm gonna ban it in my fucking chat, bro. It's over for you fuckers. It's over for you motherfuckers. Y'all getting y'all getting purged, bro. Y'all getting massacred. It's your cheese for for all you fools. Moderation, boom. Settings, boom. Let's see. You could delete the message if you want now. Um, banned. Shared banned info. Modify. Block terms and phrases. There you go, motherfucker. GG's, bro. Anyone who types that shit, y'all getting banned, bruh. Always active for your channel. So what happens? Contain these terms will be blocked from chat. So I don't think you, no, you don't get banned. Just the term won't be typed out. All right, we good. We good. We good. Okay, so chat tells me behaves very similarly to the Feather NRF5240 Express board. Okay, it has an onboard regulator. What does it regulate to? 3.7? We can see it right here in real life. So the regulator, I would assume it's this guy right here. It's like a, what is that package again? It's called SOT23. 23. It's a small outline transistor. It's pretty common. I think regulators are usually like that. Could be underneath.